Hello everyone, this is Dr. I. Getsi, Department of COC, RIT. So in this video, we are going to discuss about the conversion of non-deterministic finite automata to deterministic finite automata. So already we have stated an equivalence theorem. That is, if there is an NFA N accepting the language L, then there should be a DFA which accepts the same language L. That is the equivalence theorem. So based on this theorem, if an NFA is given, then we can find or we can convert this NFA to DFA. There should be an equivalent DFA for the given NFA. So here we are going to see a problem. So the given NFA is consists of three states, right? Q0, Q1, and Q2. So this DFA describes the language containing set of all strings, that means binary strings, ends with 0, 1. That is the language which has been accepted by this NFA, right? So how can we determine that this is an NFA? For Q0, if I give input 0, it can either go to Q0 or it can go to Q1. That shows the non-determinism. So this is an NFA. Now we are going to convert this NFA to deterministic finite automata, right? So for this, we can write a statement. Let us take the given NFA is N, right? We can represent a finite automata in 5 tuple, right? So the first tuple is set of states Q, comma, input alphabet epsilon or summation, comma, the transition function del, comma, the initial state Q naught, comma, the set of final states F, right? And we are going to convert this NFA to DFA D, which is represented as a 5 tuple. Let us take Q1, comma, input alphabet is going to be the same. So summation, then del 1. So transition will be different, right? Del 1, comma, the initial state is going to be the same, Q0, and F1 set of final states, right? This is a DFA. Now, our target is to determine a DFA, an equivalent DFA for the given NFA. So, let us take the problem. So, this is a transition table for the given NFA, right? So, for Q0, if I give input 0, it can either go to Q0 or Q1. And if I give input 1 to Q0, it will go to Q0. Similarly, for Q1 and Q2, right? This is a transition table for the given NFA. Now, let us write the transition table for the given, for the DFA, which has to be determined, right? So, for the DFA to be determined, we know that the initial state is same, right? Q0 is same for both NFA and DFA. So, as of now, we have the knowledge that Q0 is the initial state for DFA also, right? So now we are going to determine the transition for this initial state Q0. So how can I determine the transition function? Let us take, so here del 1 is the transition function for DFA. So del 1 of Q0, comma 0. First, I am going to determine del 1 of Q0, comma 0. So which is equal to del of Q0, comma 0. So what is del of Q0, comma 0? So we know del of Q0, comma 0 is Q0, comma Q1. So it can either go to Q0 or it can go to Q1. But in DFA, there should be only one transition for a single input from a given state, right? Here from the state Q0, it can go to exactly one state. So let us take, this is a single state. The state is Q0, Q1. So you should represent it inside a square bracket. So inside the square bracket, you should represent Q0, Q1. Therefore, del 1 of Q0, comma 0, that is the transition function. Del 1 is nothing but the transition function of the DFA to be determined, right? So del 1 of Q0, comma 0 is equal to del of Q0, comma 0, which is Q0, comma Q1. So that should be represented as a single state, that is Q0, Q1. Next, del 1 of Q0, comma 1, which is equal to del of Q0, comma 1. Therefore, let us see what is del of Q0, comma 1. So Q0, comma 1 is Q0. So you can represent it as Q0. This can also be represented inside a square bracket, right? Now we can determine, so that we have determined del 1 of q naught comma 1 and del 1 of q naught comma 0. So we can fill this table. This is q naught, q1, and here it is q naught. So from this row, we have got a new state called q naught q1, right? Now we are going to determine the transition function for q naught q1 state. This is q naught q1. This is a new state we have got in this step. So q naught q1. Now we are going to determine the transition function for this new state q naught q1. So how can I determine? Let us erase this. Now, see del 1 of q naught q1 comma 0. So this will be equal to del. Del is nothing but the transition function for the given NFA. So del of q naught comma, this is q naught, right? Q naught. So q naught comma 0 union del of q1 comma 0, right? See, del 1 is transition function for the DFA, which has to be determined. Now, del is nothing but the transition function of the NFA. So, del 1 of Q naught Q1. So, Q naught Q1 is a single state in DFA, but it's of different states in NFA. So, del of Q naught comma 0. Let us see what is del of Q naught comma 0. So, del of Q naught comma 0 is again Q naught comma Q1. So, you can represent it as Q naught Q1 union del of q1 comma 0. q1 comma 0 is q1 comma 0 is 1, right? The q2. So here q1 comma 0. q1 comma 0 is pi and q1 comma 1 is q2. And here q1 comma 0, that is pi, which is equal to q naught comma q1, right? So this should be written as q naught q1, right? Eliminate comma. So it should be represented within a square bracket q naught q1, right? And then you can determine del 1 of q naught q1 comma 1, which is equal to del 1 of q naught comma 1 union del, right? Del. This is not del 1, del union del of q1 comma 1, right? That is q naught comma 1 union q1 comma 1. Now q naught comma 1, del of q naught comma 1 is q naught. So here put q naught union del of q1 comma 1. So del of q1 comma 1 is q2, right? Q2. So here it is q2. So when you union this, you'll be getting q naught q2. Since this is a DFA, it should be represented within a square bracket. That is, both are not different. It is a single state. So q naught q2. Now, let us fill the table. Del 1 of q naught q1. That is, for the state q naught q1, if I give input 0, it retains in the same state q naught q1, right? If I give 1 as input to the state q naught q1, it will go to a new state q naught q2, right? Let us fill this. So here q naught q1, and for this entry you should write as q naught q2. So from this step we have got a new state called q naught q2, right? Q naught q2. So our next step is to find transition for this new state q naught q2, right? So from the second step, we have got a new state q naught q2, and now we have to determine transition for this new state q naught q2, right? Let us see the transition. right? So now del 1 of the new state we have got now is Q naught Q2 comma 0. For this, del of Q naught comma 0 union del of Q2 comma 0. Therefore, del of Q naught comma 0 is, we know Q naught comma 0 is Q naught comma Q1 union del of Q2 comma 0. Let us see, Q2 comma 0 is pi. So this is pi. Now we'll be getting Q naught comma Q1. It should be represented as within square bracket Q naught Q1. Right? This is a transition for zero transition for Q naught Q2. Now let us write for Q naught Q2 one transition. Let us erase it. Now here del of Q naught Q2 comma 1, which is equal to del of Q naught comma 1 union del of Q2 comma 1, which is equal to Q naught comma 1 is Q1, right? Union Q2 comma 1. Q2 comma 1 is pi, right? Pi. So Q naught comma 1 is Q naught. Q naught. Q naught comma 1 is Q naught, which is equal to Q naught. So it can be represented as Q naught, right? So let us fill the table. So Q naught, Q2, we have determined transition for the new state Q naught, Q2. So here it is Q naught, Q1, right? Q naught, Q1, this one. And for the second, Q naught. So here it is Q naught. Now at this step, we haven't come across any new state, right? So analyze the entire table. In the first row, Q naught, Q1 state is there. We have already determined transition for the state. Q naught, we have already determined. And for the second row, Q naught, Q1, already we have written. For Q naught, Q2, we have written. Then Q naught, Q1, yes, completed. For Q naught also completed. So all the states have the transitions, right? So now we are going to draw the transition table. Let us see. So for the DFA, Q naught, Q naught, Q1. This is our target DFA, not target DFA. So Q naught, if I give 0, Q naught, Q1, and for 1, this is for Q naught, Q1, right? Then for Q naught, Q2. Right. Now, we are going to draw the transition table for this, transition diagram for this table, right? So we have three states. One is Q naught, another one is Q naught, Q1, and Q naught, Q2. So before constructing or before drawing the transition diagram, we should mark the initial state and final state. See, here we know initial state is Q naught, right? It is Q naught. So Q naught is my initial state. But so Q naught, Q2, which one is the initial final state? So final state in the given NFA, Q2 was the final state, right? Now for DFA, whatever the states, see here, there are three states. In all the three states, we have to find whether which state is having the state Q2, right? Q2. So now this state contains the state Q2. Now it is marked as final state, that is Q naught, Q2, right? Q naught is the initial state and the state which contains Q2 is marked as final state, right? Now we can draw a diagram. Say for example, here this is Q naught. Q naught is my initial state. And from Q naught, if I give 0, it goes to a new state Q naught, Q1. So 0, this is Q naught, Q1. This is the new state. And if I give 1 to Q naught, it will be in the same state. And for Q naught, Q1, if I give 0, it will be in the same state. If I give 1, it goes to a new state, Q naught, Q2. And this is final state. So put double circle. And for Q0, Q2, if I give input 0, it goes to Q1, sorry, Q0, Q1. So if I give input 0, it goes to Q0, Q1. And if I give input 1, it goes to Q0, right? So Q0. Right? So this is the transition diagram for the DFA. So as of now, we have determined the equivalent DFA, right? So this is what my DFA is, or you can replace the state. That is, you can mark it as A, and you can mark the state as B, and you can mark the state as C, which is the final state, right? You can put the same transition 0, and here it is 0, and here it is 1, here it is 0, and here it is 1. Right? So this is my equivalent DFA. So this DFA will accept all binary strings that ends with 0, 1. Right? Thank you.